Alright, welcome to the last, for now, video on divisibility rules. We're going to talk about some numbers that we haven't gone over, namely 6 and 11. Okay, 6 will be fairly quick. This is the first one that basically you're going to try to meet two different rules, right? So anything that's divisible by 6 is going to be divisible by 6's prime factors. In other words, right, 6 is 2 times 3. So if it's divisible by 3 and by 2 at the same time, then it's going to be divisible by 6. And so you simply take a number such as 485, and you can already tell, okay, it does not meet the test for divisibility by 2 because it's not even. So therefore it is not divisible by 6. What about 584? Okay, that is even. It's divisible by 2. And then is it divisible by 3? Well, let's do what we do. Add up the digits. 13 plus 4. 17 is not divisible by 3, so no. What about 554? It is even, check. And its digits add up to 14, so no, it is not divisible by 6. What about 564, right? You can tell I'm looking for a number. Alright, that adds up to 15, so it is divisible by 3, since 15 is divisible by 3. Right, so I'm adding the digits. 15 is divisible by 3, or if I add up the digits of my 1 and 5, I get 6, which is, right, if it's 3, 6, or 9, it's divisible by 3, and it is even. So this one is, therefore, since it's divisible by 2 and 3, then it is divisible by 6. Alright, so for 6, you just use two different rules and check and see that that works. 11 is pretty cool. I'm curious what you think. Can you see a pattern when it comes to multiples of 11? Right, same way that we built, I'm going to write those out. Same way that we built some of our other ones. Alright, this one's pretty clear. I mean, the rule isn't clear, but so far the pattern seems to be clear. You have those, well, and then you have that, and then this, and then, okay, I wonder, 143, and so on and so forth. Alright, so you can stop the recording, see if you can figure out a pattern for divisibility by 11, and come back and see what I use as a 11 divisibility rule. As a hint, it helps to look at, you can pull out your calculator for this, helps to look at a bunch of different multiples of 11, 3 digits, 4 digits, etc. Okay, welcome back. Alright, so I've got a bunch of multiples of 11 here. 3 digits, 4 digits, 5 digits, ooh. Well, from 11 to 99, it's pretty clear the digits are the same. Interesting. Okay, but beyond that, 110, 121, 132. Well, one interesting thing you might notice is that the outside digits add up to the inside digit. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. We could try this with some other numbers. 2 plus 2 is 4. Right, that's also a multiple of 11. Let me give you another example of one. 11 times 52 is 572. Right, so 5 plus 2 is 7. So that might be another pattern when it comes to multiples of 11. It seems to work with a bunch of 4-digit multiples of 11 too, in the sense that rather than outside and inside, we're going every other digit. So if I look at digits that are 2 spaces apart and add them up, right, 1 plus 3 is 4, and 3 plus 1 is also 4. Right, in the same way that over here, 5 plus 2 is 7, and 7 is by itself, so there you have it. Here's a big multiple of 11, and here, right, 8 plus 2 is 10, and 5 plus 5 is 10, and you can kind of imagine how that happens, right, because I've got 1 and 1 in the ones place and the tens place, so apart by a factor of 10, and you can imagine how that might come about. So those are some 4-digit numbers. Here's another one. 6 plus 3 is 9. 8 plus 1 is 9. So it might be the case that if you add up alternating digits in your number and they are the same, that must be a multiple of 11. Here's another one. Right? Here we're going to 5 digits. 4 plus 7 plus 1 is 12, and 9 plus 3 is also 12. Right, these are all multiples of 11 that I've written over here. All right, so alternating digits add up to the same number. Okay, but what about this one? 9 plus 5 is 14, and that's not 3. 8 plus 7 is 15, but that's not 4. But, interestingly, 14 and 3 are, right, there seems to be a pattern here, though. How about this one? Here's a multiple of 11, where 8 plus 7 is, oh, hey, 15. 2 plus 2 is 4. Interesting. 8 plus 7 plus 1 is 16. 2 plus 3 is 5. So there does seem to be a pattern here as well, which is that if they don't add up to the same thing, like here, 12 and 12, for this number, they add up to two numbers that are 11 apart, right? 14 minus 3 is 11, 15 minus 4 is 11, 16 minus 5 is 11, 15 minus 4 is 11. So they add up to either the same number or numbers that are separated by a multiple of 11. In fact, we could unite both of those ideas and say that if I add up alternating digits, they should be separated, the two numbers, right, should be separated by some multiple of 11. Because 0 is a multiple of 11. It's 0 times 11. So these are separated by 0 times 11. Right? All of these 2-digit numbers are separated by 0 times 11. Anytime it's the same, it's basically, right, 7, 7. They are the same because they are separated by 0 times 11. These are separated by one multiple of 11. Well, let's see. 619. There's another multiple of 11. That's 11 times 5,629. I'm testing the multiple of 11 idea. 6 plus 9 plus 9 is 24 and 2. Right? The difference there is 22, which is a multiple of 11. So you can imagine just the different digits that we could have, and you can hunt for them yourself. As long as the sums of alternating digits are separated by some multiple of 11, 0, 11, 22, 33, 44, then you've got a multiple of 11. All right, I'll end this with on this note, which is, I never touch 7. 7's a hard one to get around. Any system that I have looked at for divisibility by 7, it's almost harder than just dividing it by 7 and seeing if it's divisible. But if you are game, you can see if you can come up with something. 12. What could you think of for divisibility by 12? 12, 24, 36, 48, right? You can pause the video, see if you can come up with something. Welcome back. I'd be curious to hear what you come up with. I've thought of something that's more in line with checking for divisibility by 6, which is, you guessed it, if it's divisible by 3 and by 4 at the same time, then it's divisible by 12, since 3 times 4 is 12. So you could check for both of those. Hey, but if you notice like a really cool pattern with multiples of 12, I would love to hear. I mean, and you could keep going. We've done the numbers all the way up through 12. You could look at 13. You could look at different numbers and see what you can find out. If you find something interesting, you can post it in the comments below.